Uh, we are going to begin with 2D trick. I'll just do that in here. I don't know why I typed that system. Switch to a 3D graph. No, that works. Okay. There we go. 3D trig. The basis of trig, as you know, you have your circle, variable circle. As you can tell, I'm not used to this yet. And you have a line here. This would just be, I don't know, say it's that's not easy to read. Say that your angle was z, or whatever it was z. Um, your vector was z. The modulus is just x plus y modulus square root of x squared plus squared, which equals the magnitude of a line in correction, where you get polar coordinates, which you'll do in year 2, I believe. But you haven't started that part yet. At least I don't think. Anyways, I probably draw this a bit bigger. Give me a sec. Okay. Anyways, uh, uh, so bigger graph. We have sine and cosine, or cos. This is my way of imagining it. Your impersonation might differ. Why did it say impersonation? Perspective. Why would I? Okay. This angle right here, defined by sine. No, it's not. What am I doing? You can tell it's been a while since I've done actual trig. This angle here is defined as the relationship between sine and cos. So, for example, sine 90 is right here because that is at 90 degrees, which gives you 1. Then cos 90 down here, so that gives you 0. The best way to understand trig, I guess, to think of it whilst it's moving. So imagine as sine increases, cos decreases. Then as sine goes back to decreasing, cos increases, which is where you get the wave function, which I cannot draw for some reason. Look like this. Terrible, but you get the point. And then sine, yeah. Does it go up? That's okay, yeah. Yeah, you get something like this when you actually draw it out, but you probably know that, at least I hope. Yeah, then if we make this a bit more specific, sin theta over cos and tan theta, which just represents the gradient of the line, and in this case, the gradient is just an angle, which is how it is in normal maths technically as well. So if you had y equals m plus c, you had a line of this. This is like y equals x. So this could be 5 technically, but it's balanced. So we say it's 45 degrees. Like you can just tell from doing normal math. Let's say it was, I need a better line to demonstrate. Y equals, I don't want to do that. Y equals 3x. This is literally just the relationship between sin cos and the gradient function, or just gradients in general. It's where this comes from in here. It's hard to explain because they weren't invented at the same time at all. Like if I do this, it makes more sense. But before doing that, it makes no sense. Calculating angles, you get a bunch of blah blah blah. Anyways, onto the actual thing. Hopefully that explanation wasn't too terrible. 3D trig. Let's start with 2D trig. 2D trig involves even Microsoft. That one. Okay, we have a line here. Line here. And we have a line here. Let's start with the basics. Let's say, obviously, this is a right-angled triangle. So obviously, this angle plus this angle is equal to this angle over here, which is 90 degrees. Let's say, oops, this was theta. This diagram doesn't portray that well. This do theta. Okay. We could just say 90 degrees. Of which is in the ratio 1, 2. Then obviously you know theta in this case is 30 degrees. Then obviously degrees over here. So that's with Pythagorean rules and stuff. Because we know stuff like 3 times 4 equals 5. You can get angles, blah blah blah. That's with Pythagorean rules, generic Pythagorean rules. Let's say we were evil and we didn't want to use a right angle triangle because, I don't know, the world wronged you and you didn't have one available. Eesh, doesn't. Okay. Say you just had a generic three-sided triangle. This is awfully similar to just an equilateral triangle. Don't worry about it. Anyways, they have theta here. There we go. We have a length here of centimeters and of 5 centimeters over here. I know it's not drawn to scale. Don't worry about it. Label this big A or little a. A. B. If we want to find this side over here, then all we would do, we would express the relationship between the angle in a triangle and its two corresponding angles. Ooh. Adjacent, yeah, adjacent sides. We have a B, we have a C. So in a normal right angle triangle, the only reason we can use Pythagoras is because of that right angle. One of the sides is constant, or two of the sides form a perpendicular point. That I'm choking. We form a right angle, basically. Simple as that. Without a right angle, we don't have a constant, so we can't just express the relationship between sides and different lengths and blah blah blah. So instead, in this case, it works surprisingly similar. Like it's hard to tell for new students when they come into trig, that when you're doing a squared plus b squared take 2bc cos a, what you're actually doing is a actually I should put this equal to something. This same a squared plus b squared. But because you're stretching this triangle to form either a smaller or potentially larger angle than 90 degrees, you need to take away a given constant. Explaining why you do that is a bit difficult, I can't lie to you. The best explanation I could give is relating it to tan, and then doing tan minus 1 of different numbers. So you could try 4, you try 5, or random numbers. It's surprisingly fun. Okay, doesn't work all the time. But you'll see that cos has special properties at a certain point when you bend angles in a triangle. The other way to do it is by making a bigger triangle in a sine graph and then just measuring that, then seeing the relationship. Although I wouldn't recommend that all the time because it takes a while to notice. Anyways, this forced to memorize for GCSEs. Not proving it today because I don't have time. I could use induction, but it's really long. Anyways, it would just be 9 plus, not 9, 9 plus 25. Take 2, 15 times cos of theta, which is then equal to, oops, then equal to 34. Take 30, take theta, which is finally equal to 4 take 2 of theta, square rooted, of course. Then we'll find this. I don't know that for sure because I've just made this up, but who knows, it might work. Next, we could move on to using trig in actual scenarios. So one of them, well, okay, one of them being with just generic model, like generic modeling. So let's say we had plane, we have a ladder. Yes, this is the ladder. We have this ladder, and we want to find the angle, the horizontal. In fact, I won't even use theta this time. I'll just use angles to the horizontal. We know that it's 5 meters away from the wall, and it is meters. In fact, we won't even get that. 5 meters away from the wall. Calculate the angle to the horizontal. Oh wait, you would actually need that. Say, ruler. Ladder is. Whoops. Not just label it here. 6, 7, 8 is no 12 meters with constant. Give me a sec. Pack. Okay, you asked about a dress. Looks nice. Anyways, we have 12 meters, 5 meters. This would be 5 over 12. Nope. I'm bugging. And on. What have I done? Why would I do that? This was meant to be 13. Then this calculated sine minus 1 5, 12. Which keep revealing the answer. Like you already know, but like, so annoying. I am calculating the wrong thing here. Oh wait, I was right. And then if we wanted the height of the ladder at the moment when against the wall, we could just do regular Pythagoras. 13 squared, take 5. 8 squared. 169 take 25 equal. What am I doing? It's just 144 equal to 12 meters. It also becomes useful in other scenarios, although they're a bit more complicated. Sorry again, give me a sec. J'y suis retourné. I forgot to speak French. Could just start saying this in French. Ah oui oui. Alors, il y a deux méthodes, incluant euh, un, un euh, c'est prédictrique. C'est vraiment stupide. Euh, méthode 2 ou 2. Ah, yeah, ouais. C'est c'est des trucs sur la plane. Vraiment agaçant. Obtenir l'angoisse. Sounds like gibberish, I can't lie. I'm rusty in French, don't worry. Although if someone wants me to like speak in French, I could be like, Bonsoir, madame. I forgot. Oh, I can't speak French. Wait. Bonsoir. Comment ça va? Ça va très bien, merci à tu. Et tu vraiment, vraiment très bien. Qu'est-ce que tu as fait le week-end dernier? Le week-end dernier, euh, je m'appelle. Je m'appelle. Ah, j'ai fait du shopping avec ma famille. Euh, c'est vraiment, ils c'est vraiment nul parce que mon père c'est trop agressant et mon mère petite être euh, un peu. No, my French is bad. It's been too long. I need to do French again. Anyways, what was I gonna do? Yeah, pretty trig. Um, pretty trig. Nothing changes. I don't know why you asked me to do this. It also has a lot of errors. So I'm doing the ugliest 3D trig possible. Okay. We have the trapezoid thing. I don't know what you call this. Let's say I want to find the line the equation. Is that too much? Yeah, that's too much. I'll leave the equation of the line a different time. I don't know if you know how to do that. Um, Oh wait, you've done triangles in pure, so probably. Yeah, I'll leave it out anyways. Um, Mainly because I don't trust myself. Can you move these? Okay, thank you. Good enough. So let's say we add this angle and make it even better. I'll just use algebra. X. So X. Ignore how it's slightly out of proportion. Let's say this part over here is no. Call this lambda. Why can't I? Close enough. Um, let's say I want to find lambda. 1 sec. Okay. So we want to find this right here. We have everything we need except angle. Let's call this angle. What do I want to call that? Mu? That's not close enough. We could use 3D trig to calculate the value of this. Or we could use integration. Either way it works. Don't know which you would prefer. Integration is really cool in this way because you just do some fancy stuff and it makes it work. If you're wondering, integration, you get the equation of the line from the origin. And this angle you just convert to a gradient function or whatever you want. You can do it however you like. You can use the formula like to or you can just do like the M1 where you have like or whatever. Doesn't really matter. You could do that using theta. Also, if you're wondering, calculating this area. Don't know why I did this in yellow. Good enough. How about any other? Okay, we're finding this triangle, obviously. We're going to use an area. So we want the area under the graph. So we could just integrate and we could do it straight away. But if you don't want to do use trig. Where you would use trig, you'd have to do it step by step. So this bisects it perfectly, as you can see. We have x, y, lambda, which we could just move over to here if we wanted, but I'll keep it up there so you can tell. Whoops. Okay. So if we want the area of this, we need this length, this length, base of side divided by 2. Okay. Step 1. Obtain this length. We already have this length. Okay. Anyways, obtain this length, which would be x sine theta. Correct me if I'm wrong. Then step 2, we just do x multiplied by x over 2, which you could just rewrite as x squared. Now this is a really easy example of why you don't need any of that, because you can tell that you get the point. It's a stupid example. This is also probably wrong. Don't mind me. I should move on to something that I can guarantee I can do, which I don't know would be matrices. I'm okay. Proof find okay. Proof. Doing proofs. No excuses. We are doing proof by contradiction first. Is a cool question on that. 1 sec. Back. We're going on 26 minutes. Jesus, blood. Oh my gosh. Okay. I'll start with proof by contradiction. That doesn't even look bad. Proof. Proof by contradiction follows a simple set of rules. Firstly, or set of steps, I should say. 1. I forgot the names. Don't judge me. It's just been a while since I've actually had to do a proof by contradiction. Assume the prime is also written poorly, but you properly get what I mean. Saying if true then false, or if false then true, blah blah blah. Then you have second step, which is prove false. And true. Statement. And you just have a conclusive step, which you can technically combine if you're good enough with your second step without actually having to do much. So to explain, you already know how to do this, but it's like common example is root 2 is rational. Oh. Yeah, we'll do rational. So if we want to prove it by contradiction, first we can represent any rational number with a fraction. We use p over q because the letters are basically nowhere in math. We want to get rid of the root, so this would become 2 equals squared q squared. Then from there, we could do 2q squared equals p squared. And then finally, q squared equals p squared over 2. This is very, very valuable. Doesn't seem valuable at first, but what it's basically saying is p squared must be divisible by 2. So hence 2 is a factor of p squared, meaning 2 is a factor of p, hence implying p a member of the integers. Otherwise 2 wouldn't be a factor. Next, you would do the same for q, and you'll just do some random stuff. Doesn't really change. I mean, you could technically do it from here and just say, considering I did this simple. Considering is factor of z implies that q squared is vector, which then implies q is a factor of p squared. Therefore, you. This is probably the wrong way to prove it, but you get how it works and everything. Also probably making you angry because I made something really stupid happen. You get the point. Like, proof by contradiction doesn't change and everything. They all follow the same rules. Proof by exhaustion works the same. Let's say it was proof. Pretend I spelt this well. Proof by exhaustion literally only follows one rule. Technically. Okay. Give me 10 seconds. Back. Anyways. Proof by exhaustion. Simple. You learn it in AS for a reason. Thank you for that. Very nice of you. If I said prove the factor of 2 squared. That's a terrible thing to write. Factor squared for all the values Wait, Chinema, pause. You just. But at the time. Manager. That's a you problem. That's so me. Annoying. Probably something stupid. Yes. Okay, I feel like you've done something. I feel like I feel like you've done something there to deserve that. I should feel offended by that, Shnibba. Then how did she work? No. No, but even then, she can't. How do you do anything? Because she can't read, so how's she meant to type? That's sad, bro. Yeah. I mean, if she didn't thrive, it would be a bit concerning. You left my door wide open, by the way. Can you not? I mean, I'm not, but like, it does, because there's nothing on my screen. My laptop, Shinema. Yes. You know, later I get to show you my work. That was at least it wasn't. I was just like me. Hey, now I have to. Oh, back. Okay, proof. Blah blah blah. I'm wondering. Hope you want. I'm still doing this. What do you want me to? Shinema, what are you doing? Thank you. Okay. Uh, this sign just means factor of. You might have seen it somewhere. So instead of saying 4 divided by 2 or something, you could literally just say 2 is a factor, um, which saves a lot of time when you're doing something like, I don't know, step or the AEI, because you really don't want to be spending time on that. Anyways, moving on, we can do proof by proof by infinite descent. I can't teach you, so I can teach you proof by induction. Um, so you should know um the previous two proofs quite well because you learnt them. So proof by induction you haven't covered, although it's very similar to proof by descent, which is basically you inferring that an infinite series um, terminates in a way, or that it doesn't terminate and then has different solutions. Anyways, proof by induction is only used for uh, numbers that are only integers. In fact, it's so many integers that we usually only use um, natural numbers. Anyways, um, why is that bracket so wonky mess? Close enough. Anyways, Starting off, we have three different ways we do it in AS for further maths. Then you'll also have a way to do it in levels for further maths, although they won't show you where you have something like, I don't know, summation n r equals infinity, back to the other way around. Blah 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 blah. Yeah, it's ugly. Thank goodness I'm doing AS. Essentially, let's say I wanted to prove a summation formula. We'll choose the generic one. This literally means 1. So when r equals 1, 1 plus 2 plus. So we reach n plus plus. When do I write 6? N minus 1. This is what the summation formula will do. And it equals. Okay, summation formula. You'll learn it eventually. Don't worry. You plug in your value for n, it sums it up till that series. The way it works is that you take the middle term, 2 plus 4, 1 plus 5. You'll realize they equal the same thing. So 2 plus 4 is 6, 5 plus 1 is 6. Works for larger series as well, which is why we half it. It's like doing the area of a triangle and having each term increase by a steady amount, but at the same time, it equals the same thing. Anyway, don't worry about that. And so we wanted to prove this formula. So prove formula that I drew a line somewhere. Don't worry about that. Proof formula. The way we're going to prove it is with 2 or 4 steps actually. One, the base step, which is where we show it true or 1. So we need to plug n equals 1 into n, substituted basically. Then the second step is the assumption. True. Okay. Then the final step, step 3, is inductive. Trust me when I say these are ends. True for n equals k plus 1. Finally, we have the conclusive step, which is the conclusion. Okay. So I'll quickly write out the formula again for you. So you have we're trying to prove this. So if we do it step by step, have step 1. Okay, so and then we have no, just checking or just showing you this just means left hand side of this. 1 over 2, 1, so just be 1 over 2 times 1 plus 1 is 2 equal to 1 RHS or right hand side. Therefore, shown through 4 equals 1 to an assumption why not add a why didn't I do that? Also there we go. They said this K1 I made a stupid here, the that's still N, never mind. We're saying this is equal to 1 over 2 K K1. We're assuming it works for every number. Then step 3 is the showing through the inductive step. Where it's good to know how to do some summations, though you don't actually need them. Like the way my teacher does it, okay, summation, you total the numbers. So you go 1, 2, 3, 4, blah, blah, till K. Then you do the last term, which is just K plus 1. So you add K plus 1. And we have the assumption for K. So you just do this plus K plus 1. I do it by splitting the summation because it saves time. Okay. We're going from 1 to K, then adding K to K plus 1, which brings us to this. So we know what 1 to K is because we assumed it true. 2K 1 plus K plus 1. We just insert it into here. And then what we want to do, we want to get this current equation or its expression to look like this. So every n should be a K plus 1, which we can do by factoring out K. So I'll put brackets around here, is equal to K plus 1 1 from 1. You can factor out a half. And you'll notice if we factor out a half, we get K plus 2 is not what we want. So instead, out 2 K plus 1 funniest thing that nobody sees it immediately. Hopefully you do. 1 1 is exactly the same as 1 over 2. And you can see this, same as this, same as this. Doesn't look like it. We just substituted K plus 1 for n, blah blah blah. You get results. Um, in full step, therefore true. Mm, There are numerous ways to answer this, but like this is my preferred method. Um, Mainly because you make less mistakes. There's also ways you can do it, like then you just I wouldn't worry about that too much. Um, Anyways, this is proof by induction. What other proofs are there that I can show you? Well, do a we do have proof by infinite descent, although I don't know how I would teach that. So instead, I'll just do own other proof, which is proof by algebraic rearranging and blah 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 blah, blah stuff. Uh, you already know this. Let's say we want to prove that the square of an integer. So square of a even number is divisible by 2. So, oh, that's too easy. Square of an even number is not okay. Let me do a contradiction one first. So odd not divisible 2. So assume if being fine because I can't be asked, then you already know what to do. Bear in mind I said ask, not asked. Divisible by 2, so that'll be 2 and 1. I chose plus 1 because I like the numbers. Which is just equal to 4 and I'm not bugging, yeah. Plus 1, which comes can't take out 4. 4 and add now we can take out 4. Just because and but we wanted to prove that this should be divisible by 2 and not a set of the even integers which plus just do natural numbers, do integers. I don't know if I'm allowed to do that. Maybe I just skipped the whole thing. I don't know what I would call that. This notation, don't worry about it either. Sorry about that. But the normal one will just be like prove uh for a factor of um addition to squares. If you wanted it in a different form, you could say and two even squares would 10. Has to be even. 2. So this is really simple. Made a mistake. So then 2. Factor of proofs don't change, although my statements are off for some reason. Maybe it's because I did too many. But like you get the point. Like it works. Because it's really simple. For more complicated proofs, you will have to try a bit harder. So one of them being a squared plus b squared over a 1k squared. Prove true for some integers. So 1, 1, that would be 1 plus 1 over 1, 2, is a factor of 1 squared, which itself is a natural. So this works. What else would that be? 4 and 7, maybe? So that'd be 16 plus 49. 65. That would not work. But this is like a harder proof that you. This is the IMO one that I sent to Electra. I gave it to my math teacher today. He broke down a bit. Process. He was like, "Oh, why are you wasting my lunch?" He spent 40 minutes on this thing, and I was just watching, and he did so well. Then all of a sudden, it just stopped, and it was like very good, and then also very bad. Um, what's another proof? Oh yeah, have a triangle. Let's pretend this circle is inside the triangle. Um, such that the radius r um a a we want to prove 2 times the radius is equal to b plus. This proof is relatively simple if you just draw more lines. So this is r. So we have a box essentially. It's best I show that in. So our little box friend thing helps us work out everything else. Then we learned that this shows that, say, this is lambda, this is lambda, and this is mu, and this is mu. So we're basically saying this angle equals this angle because it bisects, because theorems, you know, two tangents to the circle meeting at a point give the same angle. You bisect it because then you can form a straight line, blah, 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 blah. But eventually, delete so much before I delete the right thing. Anyways, we can say this angle equals this angle, this angle equals this angle, and then the best thing I did was draw a line. No, it's giving me an error, just ignore it. This to show that this is perpendicular. Then only then does it give you some more hints. So you can use cosine, you get other stuff. You'd also just say, because we have the box, this is just take R, is C take R. Then obviously C take R, um, in a sec. After doing a sufficient amount of trig, you get that this ignore how bad this is, by the way. Take R, therefore D take R, D take A, therefore D, D, uh, 2, A, therefore D take A equals 2R. I don't know why I wrote it like that, which is exactly what we tried to prove. Yay! Technically, this proof is wrong because we're assuming this the same as this. That's not always going to be the case. You can have a triangle that looks like this. A ball inside of it, or circle, and then you would have this length being completely different. So you can use the same assumption. You can still do it, but you'd have to use Pythagoras in a really funky way. With a lot of variable, it wouldn't be nice. Yeah, but I mean, it works. Now the only what to I can expand binomials. Oh my goodness, I've already messed up. X to the 4 plus x 6 squared plus 4x plus 1. I do 8 cubes plus 24. I already messed up. 24 times 3, 72 plus 3, this would be 9, so this would be squared. No, okay. It was a horrible idea. I'll do some more nice numbers instead. Before, this is really sick. Because then you can just take 2 out as a factor. X 1 the 4 is then just 16 x plus 4x 1 equal to yeah, okay, I thought I made a mistake. Squared the humbly trick I learned during step. I should have already known. I just never managed to actually figure it out for some reason. I beg. Okay. Should have already known this. Because it's extremely useful. let's say it was like 4x to the 9, you wouldn't want to do this. So you would instead write it out as 4 to 9, then because doing it normally is disgusting, completely ugly. You wouldn't want to do it. If you're wondering, you probably figured it out. No, he's not good. Um, if only if because a factor fact, um, you can see why it's useful to use different notations. And also, K has to be. Can you use negatives? Yeah, you can use negatives multiple. Technically, I wouldn't, but you can. It has to be a factor of both. The most important step. If it's not a factor, can't take it out. Technically, I could take out half, but like that's not going to help me ever, unless I have a half inside the brackets that I'm expanding, which is very, very helpful. So I could take out a half and then random number. But yeah. So for proofs, there was a proof question that required you to understand this fact. I think it was prove someone who's like to make sure if I substitute in 1 minus 2, that would be minus 8 plus 1 minus 7. 2 1 again. Oh no, wait. You do 2. You do 3. In fact, why am I doing 2? This would be 27 plus 0. So we want this to 7. Okay, it does. By chance, if I substitute in 2, that's minus 2, minus 8. Plus 8. I'll do some math. Minus 8. 2 take 3, minus 1. It would just be minus 1 plus 8. We want a 7. 2, 5. That does not work. What if I add it to this side? 5, that's 125. What the Oh, wait, I'm being stupid. It shouldn't work. Um, okay. 4. I wrote that really badly. It's my fault, don't worry. Then we prove opposite, because this actually ends up being false. Or as the question explains it. So, yeah, this. The expression blah blah is divisible by 54. Why did I say an int? I just m. Right is an integer an even, so a natural number. No. Prove no such integer exists. This is the part that throws people off. Firstly, you just need to show that this doesn't work for a number. So this would be prove it has to be even. That was one of the things. Prove this has to be even. So let's say we assume that it works for odd numbers. So we substitute m for odd. So that 1, that would give us 2m plus 1 minus 3, minus 2. That's n minus 2 to 3 plus 2 n 1 plus 2n, which is obviously false because even plus odd cannot equal even. If you do 1 plus 3, why did I pick 1? 2 20 even plus 41. Don't get an even number ever. So it has to be even. This part's true. Ish. Related that there are problems. Then we're going to move on to proving that it's divisible by 54. So it was just m minus 3 plus 3. There's not much you can do here. You want to simplify this? I mean, we do want to use this statement up here. I would recommend that. Although we don't have to. We just do cubes. 2m cubed. I'm counting for this. Ag. One note. Thank you very much. 2m cubed. Minus 6m. Okay. 2m cubed minus 6m will be multiplied by minus 8. Then 9 times 3. And then it'll just be 3. I feel like I'm doing something. 3 times 3 is 9. Yes. I've done something. Can't tell. Either way, this wouldn't really matter because I can still factor out. So this cube, uh, minus 27x squared. This was cancelled out. Yes, minus 50. But you can notice we got 54. So we might as well just move it to the other side to get minus 27m. Or then, even if I did make a mistake in my expansion because I did it mentally, we can still just take out m squared, which would be m squared 2 minus 7. So all we need it to be, we just need m squared to be a factor of 54. But there are no numbers that satisfy that. You can test it. Like it's not just me saying it for the fun. You can test 4, 3 doesn't work. 4. Oh, it has to be even as well. I just remembered. So it can't even be 3. Because 3 would obviously get you somewhere close. Because it can only be 2. It can only be 8 is too large. So we can immediately rule that out. Squared equals 4. Is not a factor of 4 squared. Not a factor. Squared is 6. Not a factor of. Hence, no such integer can exist. It's a really good question because it forces you to just understand proof by contradiction entirely. Otherwise, you'll kind of get lost over yeah, because you'll be like, oh, okay. I mean, I proved m squared is divisible by 54. What do I do next? But I mean, some people get stuck here, some people don't. I've also done a lot of proofs. I just realized. But, oh my goodness, I did more than I thought. I should probably end it here. Okay, have fun. Goodbye.